Do you live in Illinois, Indiana, Ohio, Pennsylvania, or New York? Do you live along the northern tier of the United States, from Oregon and Washington in the Pacific Northwest, all the way across to Michigan, Wisconsin, and Minnesota? Do you live anywhere in Canada, from British Columbia to Ontario to Quebec? If the answer is yes, you need to stop what you're doing right now and pay attention, because what is barreling toward Earth tonight is not a typical space weather event. This is something that scientists have a specific and unsettling name for. They call it a CANNIBAL CME, and it is headed directly for our planet. Right now, as you watch this video, the sun has done something it does not do every day. In less than 24 hours, one single sunspot region, a violently unstable patch of magnetic chaos on the solar surface called active region 4455, fired off 3 enormous eruptions back to back to back. Not one, not two. 3 massive solar events in under a day, each one launching a cloud of magnetized plasma hurtling outward at hundreds of miles per second. And those clouds are not traveling separately. The fastest one has already cannibalized the one in front of it, swallowing it, merging with it, growing heavier and more energetic as it flies toward us. And now forecasters at NOAA's Space Weather Prediction Center are watching closely to see if a 4th component joins the mass before the whole thing slams into Earth's magnetic field tonight. NOAA has issued a G3, strong, geomagnetic storm watch, active right now for June 4th and June 5th. But here is the problem. A G3 is not the ceiling tonight. Forecasters have stated explicitly that isolated G4, severe, conditions are also possible if this CANNIBAL CME arrives with a southward-oriented magnetic field. That one variable, the direction that invisible magnetic field is pointing when it arrives, could be the difference between a spectacular aurora display and a storm that begins causing real problems for the technology billions of people depend on every single day. The timeline has already begun. Let us walk through exactly what happened, exactly what is coming, and exactly why tonight matters far more than most people realize. It started quietly enough. On the evening of June the 2nd, active region 4455 fired an M3. 3 flare. Moderate by solar standards, but notable because of which region it came from. Forecasters were already watching AR 4455 with intense interest because of what it is. This is not a normal sunspot. Scientists describe it as having an anti-hail configuration, a reversed polarity magnetic structure that makes it fundamentally more prone to explosive, unpredictable releases of energy. The magnetic field lines in an anti-hail region are wound in the opposite direction from what is expected, creating extraordinary internal stress and instability. Think of it like a coiled spring under enormous pressure, except that spring is made of superheated plasma millions of miles across. Then, at 1:36 in the morning, UTC on June 3rd, that is 9:36 p.m. Eastern Time on the night of June 2nd for viewers in the eastern United States, AR 4455 erupted with its first major strike. An M9, 3 solar flare. To put that in perspective, the M-class scale runs from M1 to M9. 9 before crossing into X-class territory. In M9s, 3 is as close to an X-class flare as you can get without becoming one. The explosion sent a radio blackout racing across the sunlit side of the Earth. Australia went dark on high-frequency bands. East Asia saw communications degraded. Pilots, maritime vessels, and military operators monitoring those frequencies noticed the disruption within minutes. But that was only the opening act. 5 hours and 24 minutes later, at 7:00 a.m. UTC on June 3rd, AR 4455 fired again. An M7 flare. Another powerful eruption, another radio blackout, this time slamming Europe and Africa with R2 level disruptions. 2 major flares from the same sunspot in less than 6 hours. Forecasters were now on full alert. The region was growing more complex, not calming down. And this next part matters. Because just 4.5 hours after that, at 11:28 a.m. UTC on June 3rd, 7:28 in the morning Eastern Time, AR 4455 crossed the threshold. It produced an X1, 0 solar flare, a full X-class event. NASA's Solar Dynamics Observatory captured the explosion in real time. The X1 flare triggered an R3, strong, radio blackout, disrupting high-frequency radio communications across a wide swath of the sunlit hemisphere. 3 major eruptions. 3 CMEs launched toward Earth, all within a single 24-hour period. Now here is where this becomes dangerous. When a solar region fires multiple CMEs in rapid succession, something remarkable and alarming can happen in the space between the Sun and the Earth. The faster CME, launched later but traveling at greater speed, catches up to the slower CME that left first. When it does not simply pass by. It collides and merges with it, incorporating the other cloud's mass and magnetic field into its own structure, growing larger and potentially more powerful than either individual ejection. This is what scientists call a CANNIBAL CME. And, NOAA's Space Weather Prediction Center has confirmed it. The third CME, the fastest of the group, has already caught up with and merged with the second one. The question now being debated in real time is whether additional material from that June 2nd M3 flare will also arrive as part of this merged structure before impact. NOAA's forecast calls for combined CME arrival around mid-afternoon Eastern Time today, June 4th, with up to G3 and potentially G4, geomagnetic storm conditions following impact. CME passage is expected to continue through the evening and possibly into the overnight hours of June 5th. Most people are missing this. The arrival itself is only part of the story. What happens after arrival depends entirely on what scientists call the BZ component of the incoming solar wind. BZ is the north-south orientation of the magnetic field, embedded inside the CME. When BZ points northward, it mostly deflects off Earth's magnetic field without causing severe disruption. When BZ turns southward, it locks onto Earth's field like a key turning a lock, opening a channel that allows massive amounts of solar energy to pour into our magnetosphere. Southward BZ is what drives geomagnetic storms from G1 to G2 to G3 to G4 in a matter of hours. And right now, forecasters do not know with certainty which way BZ will be pointing when this CANNIBAL CME arrives. That uncertainty is the reason the G4 watch is still on the table. That uncertainty is the reason tonight is not over yet. Let us talk about what a G3 storm actually means in plain terms, because most people hear the word aurora and think this is just a beautiful sky show. It is much more than that. Under G3, strong, geomagnetic storm conditions, power grid operators across the country face what engineers call geomagnetically induced currents, or GICs. These are surges of electrical current that are literally pushed through long-distance transmission lines and pipelines by the distorted magnetic field of the Earth. Power companies must make real-time voltage corrections to prevent these induced currents from overloading transformers. High-voltage transformers are expensive, rare, and can take months or years to replace if damaged. At G3 levels, power systems require active management to maintain stability. Satellite operators dealing with increased drag on their spacecraft in low Earth orbit, thousands of satellites, including commercial internet constellations, are affected during strong storms as the upper atmosphere heats and expands. GPS accuracy degrades. Aviation navigation systems at high latitudes experience disruptions. HF radio communications can be intermittently lost. These are not catastrophic outcomes at G3, but they are real, measurable impacts on the infrastructure of modern civilization. And if this event escalates to G4, at G4, severe conditions, the risk of widespread voltage control problems increases significantly. Transformer heating becomes a serious concern. Satellite operations move to heightened alert status. The risk profile changes in ways that utility companies and emergency managers take extremely seriously. But that is not the real story, and here is why. Active region 4455 is still there. It is still on the sun. It is still facing Earth. And NOAA's own forecast says it is still capable of producing additional M-class and possibly X-class flares through June 5th. The sun is not done with us. There are also multiple other active regions on the solar disk right now. Regions 4458, 4461, and 4462 are all being monitored. The possibility of further Earth-directed eruptions on top of what has already been launched cannot be dismissed. We are in the declining phase of solar cycle 25, which reached its maximum roughly in late 2024. But declining phase does not mean quiet. Some of the most intense geomagnetic events in solar history have occurred during the declining phase of a cycle, when the sun's magnetic field is restructuring and active regions can still produce explosive, unpredictable behavior. The sun does not read the forecast. It does not know it is supposed to be calming down. Now the focus shifts to what this means for you tonight, if you live in the right place. Under confirmed G3 conditions, the aurora borealis can become visible at magnetic latitudes as far south as the 50-degree line. In practical terms, that means northern lights could be seen with the naked eye tonight across all of Canada, Alaska, the Pacific Northwest, including Oregon and Washington State, the Northern Rockies, the upper Midwest, including Minnesota, Wisconsin, Michigan, Iowa, and Illinois, the Great Lakes region, and across New England. Pennsylvania, New York, and even parts of New Jersey sit at the edge of visibility under G3 conditions. If this storm briefly intensifies to G4, the viewing zone expands further south. Some aurora forecasters are mentioning visibility as far south as Iowa and Indiana under the right conditions. One more thing you need to know. June is not an ideal month for aurora viewing in the northern hemisphere for one simple reason. It is close to the summer solstice, and nights are short. Darkness arrives late and ends early. For viewers at latitudes like Chicago or Portland, the window of true astronomical darkness tonight is compressed. That means your viewing window is narrower than it would be in October or March. But it also means that if you are in the right place, if skies are clear, and if the storm delivers as forecast, you will not need to be awake until 3 a.m. to see it. The peak of geomagnetic activity could coincide with the post-sunset hours. Here is why this is serious at a historical level. To understand what a truly catastrophic geomagnetic storm looks like, you have to go back to May 2024. In that event, only 2 years ago, active region 113.664 became one of the most productively dangerous sunspot groups in decades. Over several days, it fired off multiple X-class flares, including an X8. 7, the most powerful flare in nearly 20 years. The resulting geomagnetic storm reached G5, extreme, the highest level on the scale. The KP index hit 9. The lowest DS, a measure of geomagnetic disturbance, plunged to negative 412 nanoteslas. Auroras were seen across Europe, North America, and parts of Australia. Satellite operators scrambled. Power grid engineers worked around the clock. Some GPS systems reported incorrect positions. That was a G5. What is coming tonight is forecast at G3 with a possible G4 peak. But go back even further. Back to 1859, the Carrington event, a solar superstorm so powerful that telegraph systems across North America and Europe burst into flames. Operators received electric shocks through their equipment. Auroras were seen in Cuba, Mexico, and Hawaii. The entire global communication infrastructure of that era was disrupted. In the modern world, with its web of satellites, long-distance power lines, undersea cables, aviation networks, hospital systems, and financial transaction infrastructure, an event of Carrington-scale magnitude would cause devastation that some estimates place in the trillions of dollars, and that could leave parts of the power grid dark for months. The infrastructure of our civilization is orders of magnitude more complex and more vulnerable to space weather today than it was in 1859. Tonight's event is not a Carrington event. Nobody is saying that. But it is a reminder, a direct, real-time reminder of what our star is capable of and of how little notice it gives us before acting. What happened next changed everything about how forecasters are treating this storm. When the third CME, the fastest, overtook and swallowed the second one, the merged structure began behaving differently from what initial models suggested. A CANNIBAL CME is not simply the sum of its parts. The merging process compresses and enhances the magnetic field within the combined structure. It can change the overall speed. It can alter the internal structure in ways that ground-based models struggle to fully predict until the storm actually arrives at the L1 monitoring point, the gravitational balance point between Earth and Sun, about 5 million kilometers from our planet, where NOAA's DS-COVIR satellite provides real-time solar wind data. At that point, scientists get roughly 15 to 45 minutes of warning before the storm hits Earth's magnetic field. 15 to 45 minutes. That is the margin of notice our civilization operates on for space weather events. Think about what that means for a family in Minneapolis watching this video, or in Portland, or in Cleveland. If you are in those cities right now, you are in the aurora visibility zone tonight. You are also in the zone where power grid operators are running contingency protocols. You are in the zone where GPS-dependent systems, delivery networks, aviation, precision agriculture equipment, emergency response navigation may experience degraded accuracy. Most people going about their evening routine tonight have no idea any of this is happening. No local news alert, no push notification on their phone. Just the sky overhead and whatever it decides to do after dark. This next part matters because of who else is in the risk zone right now. Approximately 800 kilometers above your head, astronauts aboard the International Space Station are monitoring this closely. The ISS regularly maneuvers its orientation during strong geomagnetic storms to minimize the crew's radiation exposure as energetic particles funnel into the polar regions. Starlink satellites and other low Earth orbit constellations are experiencing increased atmospheric drag as the upper atmosphere heats and expands under geomagnetic forcing. The same effect that caused SpaceX to lose dozens of newly launched Starlink satellites during a geomagnetic storm in early 2022, when a G1 event was enough to pull newly deployed satellites back into the atmosphere. Tonight's storm is projected to be far stronger than that. Satellite operators are not sleeping tonight. Agriculture is another piece of this that rarely gets mentioned. Precision farming across the American Midwest, from Nebraska and Kansas to Iowa and Ohio, runs on GPS accuracy down to centimeters. During strong geomagnetic storms, that GPS accuracy degrades. Automated equipment gets confused. Planting and harvesting operations scheduled for tonight or tomorrow may face unexpected problems. Farmers who have invested heavily in precision agriculture technology are silently and visibly exposed to space weather in ways their grandparents never were. And tonight changes the timeline for one more reason. NOAA's forecast does not end on June 4th. The G3 watch is active for both June 4th and June 5th. CME passage is expected to continue through Thursday night and into Friday. That second day of exposure matters. Power grid operators can sustain managed conditions for a period, but prolonged geomagnetic activity stretches their capacity. The longer the storm persists at elevated KP levels, the greater the cumulative stress on transformers and long-distance transmission infrastructure. This is not a one-hour event. This is a multi-day passage, and the sun has not guaranteed it will stop at 3 CMEs. Now here is what you should actually do right now. If you are in Minnesota, Wisconsin, Michigan, Illinois, Iowa, Oregon, Washington, Montana, Idaho, Wyoming, Colorado, Pennsylvania, New York, or anywhere in New England, go outside tonight after dark, away from city lights if you can, and look north. The aurora does not always look the way it does in photographs taken with long exposure cameras. To the naked eye, it can appear as a pale greenish or whitish glow, almost like a cloud that moves strangely, or like a subtle vertical rippling near the northern horizon. In strong storms, it can fill the entire sky with curtains of green, red, and purple that are unmistakable and impossible to forget. Tonight may be one of those nights, but look north with awareness, not just wonder, because what is causing those lights is not just a beautiful phenomenon. It is a reminder that our sun is not a fixed, stable backdrop. It is an active, violent star in the middle of an ongoing process of magnetic readjustment, and we orbit it at a distance close enough to feel everything it sends our way. Active region 4455 is not finished. It remains on the solar disk, still facing Earth, still magnetically complex, still producing flares. NOAA says M-class flaring remains likely through June 5th, with a non-trivial chance of additional X-class activity from this region and from regions 4458, 4461, and 4462. There is also a potential additional CME component from the June 2nd M3, 3 flare that forecasters say could arrive around June 6th, potentially extending this space weather episode into the weekend. The CANNIBAL CME is on final approach. The merged cloud of solar plasma and twisted magnetic field is somewhere between Earth and the Sun right now, covering distance at millions of miles per hour. When it reaches the Diascovier satellite at the L1 point, the world's space weather forecasters will have their first definitive look at exactly how intense this storm will be. Within minutes, that data will stream to Boulder, Colorado, where NOAA's Space Weather Prediction Center will update warnings and watches. Within minutes after that, power grid operators across North America will make real-time decisions. Satellite operators will adjust protocols. Aviation authorities will reroute high-latitude flights if necessary. And most of the people affected by all of this, all of us using our phones, our internet connections, our GPS, our electricity, will be completely unaware that any of it is happening unless the lights flicker or the sky turns green. The storm is not a forecast anymore. The material is already in transit. The G3 watch is active. The G4 possibility has not been removed. The sun fired 3 times in 24 hours from a region that scientists are describing as deeply unstable, with a reversed magnetic configuration that makes it intrinsically more dangerous than ordinary active regions, and that same region is still there, still growing, still facing us. There are perhaps 12 to 18 hours left in the most dangerous window of this event. Somewhere above you, right now, invisible and silent and traveling at a speed that makes any earthly storm seem motionless, 1 billion tons of magnetized solar plasma is closing the final distance between the sun and everything you depend on. The next several hours will tell us whether this storm hits hard or hits harder. And AR4455 is still watching us from 93 million miles away. Still magnetically complex, still capable of firing again before it rotates away from Earth's line of sight. This is still evolving tonight. Mom, let us talk about what that looks like in the real world, not in the abstract language of space weather bulletins and KP index numbers, but in the kind of terms that mean something to an actual family in Chicago, or a farmer outside of Des Moines, or a night shift worker in Seattle watching the northern horizon. Right now, across the Midwest and the Pacific Northwest, families are going about their Wednesday evening. Kids are finishing homework, parents are cooking dinner, some people are stepping outside after the workday, noticing the air is warm and the sky is unusually clear. They have no idea. They have no notification on their phone. They have received no local emergency alert. The sun, which set hours ago from their perspective, has already sent something their way, something invisible and silent and traveling so fast, it covers the distance from the sun to the earth in roughly 2 to 3 days, and that window is now closing. Power grid operators in Minnesota and the Pacific Northwest have been in heightened monitoring mode since NOAA issued the G3 watch. These are the people who most Americans never think about. The engineers and technicians who sit at consoles and control rooms and watch voltage graphs and frequency readings in real time, ready to make corrections the moment the numbers start moving the wrong way. During a G3 storm, those graphs can behave erratically. The induced currents that the geomagnetic storm pushes through long-distance transmission lines can cause transformers to run hot, can trigger automatic protective shutdowns, can force operators to reroute power across the grid to compensate. If enough of those automated safeguards fire at the same time, you get cascading problems. You get outages, not because anything physically broke, because the storm simply pushed more energy into the system than it was designed to absorb in that moment. In 1989, a geomagnetic storm rated at G5, the same level as the May 2024 event, caused a complete collapse of the Hydro-Quebec power grid in Canada. 6 million people lost power. It lasted 9 hours. Transformers were damaged. The aurora was visible as far south as Texas and Florida. The storm struck so fast and with such intensity that automated protection systems designed to prevent damage actually triggered the collapse as they disconnected portions of the grid to protect individual components. The whole went down trying to save the parts. That was 1989. The grid today is larger, more interconnected, and in many respects more vulnerable to geomagnetic forcing than it was 35 years ago. Tonight's storm is not predicted to reach G5. But G3 with a G4 possibility is serious. And here's what most people do not understand about the G scale. The difference between each level is not linear. The jump from G3 to G4 represents a significant intensification, not just a number increment. The KP index, which underlies the G scale, goes from 7 at G3 to 8 at G4. Each full step in the KP index represents roughly a tripling of geomagnetic energy. That is, the kind of nonlinear jump that transforms a manageable situation into an emergency situation surprisingly quickly. And tonight changes the calculus in one specific way. The magnetic orientation question, the Bees problem, is not something that resolves itself until the CME is literally at the doorstep of Earth's magnetic field. Models can give probabilistic guidance. Spacecraft data from upstream sensors can offer early hints, but the definitive answer about whether BZ turns south and how far south it turns will not come until the event is already underway. This is a fundamental limitation of space weather forecasting that scientists are actively working to improve, but have not yet solved. We are, in the most literal sense, flying partially blind into this storm, and the storm is already in the mail. Here is why this is serious for infrastructure beyond just the power grid. The Global Positioning System, GPS, that your phone uses for navigation, that Amazon's delivery network uses to route millions of packages daily, that air traffic control uses to track aircraft, that precision farmers use to guide their equipment, that emergency responders use to navigate to your door, is a system that relies on radio signals from satellites passing through the upper atmosphere. During strong geomagnetic storms, the ionosphere, the electrically charged upper layer of the atmosphere, becomes turbulent and irregular. It bends and distorts GPS radio signals in unpredictable ways. This causes what engineers call ionospheric scintillation. Your GPS might still show a position, but that position could be wrong by meters or tens of meters. For a delivery driver, that is inconvenient. For an aircraft executing a precision approach to landing in low visibility conditions, that is something else entirely. For a surgeon in a hospital using GPS-guided robotic equipment, that matters. Across the board, at G3 and above, precision navigation becomes less precise. High-frequency radio communications are also affected. These are not just the domain of ham radio hobbyists. HF radio is the primary communication system for commercial aviation over oceanic routes. The Mid-Atlantic and Mid-Pacific, where aircraft are too far from any ground-based tower for conventional communication. Pilots crossing the ocean tonight between Europe and North America, between North America and Asia, will be operating in a communication environment that the G3 storm is actively degrading. Airlines maintain contingency protocols for exactly these scenarios. Dispatchers and air traffic controllers are already adjusting. Some transoceanic routes may be shifted to lower latitudes to reduce exposure to the most intense ionospheric disruption. But that is not the real story, and this is the part that should make anyone paying attention uncomfortable. The real story is about the sun we do not currently know. The sun has a far side, a hemisphere facing completely away from Earth. We have limited visibility there. Active regions can form on the far side, grow for days, and then rotate into Earth-facing positions with almost no warning. Right now, forecasters are watching AR 4455 because it has already shown its hand. But there are other regions on the disk. There are regions approaching from around the limb. We are still in a period of elevated solar activity, even as solar cycle 25 trends toward its declining phase. The October 2024 solar maximum does not mean the sun has become safe. It means the peak has passed. Events at this level of intensity, multiple major flares from a single unstable active region, CANNIBAL CME formation, G3 to G4 geomagnetic storms, can and do happen throughout the declining phase of a solar cycle. There is a saying among space weather forecasters: the worst storms of a solar cycle are not always at the maximum. Some of the most extreme events in recorded history arrive during the declining phase, when the sun's magnetic field is reorganizing and occasionally produces dramatically structured active regions. The 1989 Quebec blackout occurred during the declining phase of solar cycle 22. The 2003 Halloween storms, which included the most powerful solar flares ever recorded at that time and caused power outages in Sweden and satellite losses worldwide, occurred during the declining phase of solar cycle 23. Tonight's event is happening during the declining phase of solar cycle 25. Most people are missing the broader context, and the broader context is this. We have spent decades building a civilization that is exquisitely, invisibly, and largely unknowingly dependent on stable electromagnetic conditions near Earth. Our communication systems, our navigation systems, our financial transaction infrastructure. Global banking relies on precision GPS timing signals to timestamp transactions. Our power delivery infrastructure, our satellite networks. All of it exists within a thin electromagnetic shell around a small planet orbiting an active variable star. And the star sets the terms. Go outside tonight. If you are in Oregon or Washington State, step away from the city glow and look north after dark. After 10 p.m. local time, when the sky gets as dark as June allows. If you are in Minnesota, in Wisconsin, in Michigan's Upper Peninsula, in the northern tier of Ohio or Pennsylvania or New York, find a dark spot. Turn off your porch light, let your eyes adjust, look toward the northern horizon, and scan slowly upward. If this storm delivers as forecast, you may see something that millions of people saw during the May 2024 storm and described as one of the most moving experiences of their lives, a sky that moved. A sky that pulsed and shifted. A sky that reminded them, in a way that no article or documentary ever quite manages, that we are not standing on solid ground at the center of a stable universe. We are on a spinning rock inside a magnetic bubble, surrounded by space, and the sun is not finished with us today. The CANNIBAL CME that AR4455 has sent our way is a messenger. The message is that we are closer to our star than our daily routines suggest, and the storm is still developing. NOAA's Space Weather Prediction Center is updating its forecasts in real time. The SWPC website, SWPC.NOAA.gov, will show you live KP index readings as they come in from ground-based magnetometer networks across the globe. When the KP hits 7 and the G3 threshold is formally crossed, alerts will fire. When and if it hits 8 and the G4 threshold is crossed, a new level of response begins. Power companies, satellite operators, aviation authorities, military communication systems, they are all watching that same number. And somewhere between the sun and the Earth right now, the merged CME is still closing the distance. The BZ component is pointing in a direction that will not be confirmed until it is almost too late to change anything. The storm is in the pipeline. The watch is active. The grid operators are monitoring. The satellite teams are on alert. And most people, going about their Thursday evening, have no idea that the sky above them might be about to do something extraordinary, and that the infrastructure beneath it is about to be tested. AR4455 is still there, it is still active, it is still unstable, and it is still facing Earth. The next 12 to 18 hours will decide a great deal, but they will not decide everything because the sun is not finished. There are additional CME components, potentially still inbound. The region itself could fire again before rotating away. And the storm that is already in transit is large enough, complex enough, and uncertain enough in its final configuration that nobody, not NOAA, not the UK Met Office, not ESA's space weather teams, can tell you with certainty right now whether tonight ends at G3 or escalates to something more serious. What we know is this: the watch is real, the data is real, the flares happened, the CME was confirmed by satellite imagery, the CANNIBAL CME merger was confirmed by NOAA. The G4 risk has not been taken off the table. And the sun, 93 million miles away, is still rotating AR4455 toward the center of the solar disk. The most geo-effective position, the sweet spot from which Earth-directed eruptions are most dangerous. Stay aware tonight. Keep your phone charged. Know where your local emergency alerts come from. And if the power blinks, if the northern sky suddenly lights up in ways you have never seen, you will understand what you are looking at and why it matters. The atmosphere is changing. The magnetic field of the Earth is being tested, and the storm has not finished arriving.